Hello, geometry students, and welcome to Chapter 10. We've finished our first online chapter here, and we're entering into our next one, which is going to be Chapter 10, which is going to be on circles. And this may end up being our final chapter of the year, depending upon how things work out with all this online learning and how the year wraps up. But more than likely, this will be our last section we're going to get to. And we're going to be spending a lot of time on circles today. This whole chapter is actually going to be on circles, but the homework today is actually going to be extremely quick, really easy stuff, but the stuff we're going to introduce in class is going to take a little bit of time here. So this video gets a little bit long, but that's just because there's a lot of information and a lot of vocabulary. Remember, I'm going to go through the things quickly. If you need to pause the video to write things down, please do so. And I'm going to keep on rolling. You can always pause and start over. So to start with, section 10.1 is called arcs and central angles. And those are both new ideas to you. So we're going to start with some vocabulary to help you understand the terminology within this section. So our first vocabulary word here is going to be an arc. An arc is a part of the outside of a circle. For example, as you see my little cursor here, going from A to B, this is an arc. It's also an arc if you would go on the outside from A to B, the longer way. Those are both considered arcs. Any portion of the circle on the outside ring is considered to be an arc. All right, a central angle. Well, we define a central angle as an angle formed by the two different radii of a circle. And so when you see the circle here, we have center C, and we have radius CA and radius CB. So this angle here, the angle that rotates from here to here, angle ACB, is considered to be a central angle. It's an angle whose vertex is at the center of a circle, and it's formed by using two radii to form a central angle. So far we have arcs and we have central angles. Next, there's two different types of arcs. You have major arcs and you have minor arcs. And a major arc refers to an arc that goes more than 180 degrees, more than halfway around the circle. So in this case, our major arc, we would label in this way. We would call it arc. We draw an arc to show that's what we're describing, and we call it arc ADB. And the D is really important because it says we started at A, went through D, and ended at B. So we're talking about this large arc here that's greater than 180 degrees. It's more than half the circle. Because like we said, you can go two ways to go from A to B. You can go from A, the long way, to B, or the short way from A to B. And that short way is called a minor arc. Now the minor arc only requires two letters. We would call that arc AB. And so therefore, if you're only given two letters, we assume that we're taking the shortest distance along the circle between A and B. So that's this distance along the circle going from A to B. If you want to go the long way, in order to say we're going the long way around the circle, we have to make it a major arc, requiring us to give three letters, telling us to go from A to B, but you need to go through D. So major arcs and minor arcs simply tell us which way to go to connect the 2 points. All right, our last couple pieces of vocabulary here. Our first one here we're going to talk about is a sector. A sector is a section of a circle created by a central angle. So the arc refers to the distance on the outside of the circle. A sector is the inside. So I've shaded in blue here so you can see what a sector is. Oftentimes people remember it by thinking of it like a pizza slice. You've taken the pizza cutter and you've cut out a big piece of pizza here, going from A to C, C to B. That sector, the pizza slice, is what is called a sector. It's that one section that you've cut out. All right. Our next definition is a chord, and our picture here is getting a little bit high on the screen, but we can still see it. A chord is a segment that connects 2 points on a circle. So this purple segment from A to B, we call a chord. So a diameter is a type of chord because a diameter goes from one side of the circle to the other, but it goes through the center, so it's a specific chord. Not all chords are diameters. A chord connects any 2 points on the outside of a circle. All right, we have one more term here to learn, and that's called an inscribed angle. So you see here, this picture is a little bit different, where we still have our center C, but we're not forming an angle with 2 radii. We're forming an angle with 2 chords that have the same vertex D. So it's an angle whose vertex is also on the circle. So you have a chord AD and a chord BD forming angle ADB. So the angle here we refer to as an inscribed angle. All right, that's our vocabulary. Now let's get on to what we're actually going to do today. So throughout this chapter, we're going to measure arcs in 2 different ways. For today, we're going to measure arcs in degrees. And so therefore, we all know a circle is 360 degrees. So we're going to talk about the measure of arc AB here. This arc that goes along the circle from A to B. And we're going to try to define the measurement of that as an angle. So therefore, a degree measure is going to be less than 360 degrees because it's only part of the circle. And to do that, we're going to make a connection saying this distance on the circle in degrees is going to be the same as the measure of the central angle. So like I said, the homework of this is going to be extremely simple. If we say this is an 80-degree angle, and I'm not going to put the degree mark just to save us a little bit of time. If this is an 80-degree angle, this out here, arc AB, would have a measure of 80 degrees. So therefore, if the central angle is 80 degrees, then we could say arc AB is 80 degrees. So that's the portion of the circle, the part of the 360 degrees that has been covered. And our rule for today, the only rule in our homework is going to be the measure of your central angle is going to be equal to the measure of the arc. So let's look at a few examples of what this is going to look like on your homework. So you see this picture here. This is a really simple question. You've been given an arc measurement of 85 degrees. So your answer for the question mark, 85 degrees, because the angle, the central angle formed by the 2 radii is always the same measure as the arc measurement. So that's a really quick question, not going to take you long on your homework. Next example here, now you see it's asking us for what is the measure of angle BCD. So angle BCD, B to C to D, has to be this angle. Now this one's going to require a little bit more work because we don't know all of the angle measure directly. We don't know arc BD, so we can't use that to find our central angle. But we do know arc AF, which is 50 degrees, which means the central angle in here is got to be 50. And then you notice we have 3 angles that are all marked as the same. So therefore, this has got to be 50, this has got to be 50. Well, we have a total of 1, 2, 3, 4, 5 angles in here. I don't have a way to directly find BD, but I can use indirect information. If this arc EF is 124 degrees, then this interior angle must be 124 degrees. I'm sorry, I should have said central angle. This central angle is 124 degrees. So now we know 4 of the 5 angles. In order to find the measure of angle BCD, we can simply subtract from 360 degrees, because that's the total in the circle. I can subtract the angles on the inside, which would be 274 degrees. I just added 50 plus 50 plus 50 plus 124. And that tells us that the angle we're missing is 86 degrees. All right. This is a little bit of a higher level example. Let's move on to another one. Now, in this case, we have what's called a semicircle. So we only have half the circle here, which if a whole circle is 360, then we can say that half the circle must be 180 degrees. So if this is 25 and this is 83, that adds up to 108. If I subtract 108 from 180, I find that this arc out here must be 72 degrees. So if that's a 72 degree arc, the central angle is always the same as the arc. Our question mark angle must be 72 degrees. Like I said, your homework's going to be pretty quick today. I'm going to walk through these last couple examples, even though they aren't, I'm not going to write them all the way out, just to save you a little bit of time. Now we're finding arcs given angles. This one is really simple. If the central angle is 76 degrees, the question mark must be 76 degrees. We're done. Go on to the next one. This one's arc ABD. Now, you notice this is a minor arc from A to D. We could have just said arc AD, but we put the B in there just to show you go from A through B to D to say we want to know the measure of arc ABD. All right, to do this, we know if the exterior angle is the arc is 50 degrees, then the central angle must be 50 degrees. And if that's 50, that has to be 50 because they're marked as congruent. Now you notice AE here is not only a chord, but also a diameter, which means that that is going to be half a circle, 180 degrees. So if I know this angle is 50 and this angle is 31, that adds up to 81 degrees. By subtracting from 180, I can find that this angle must be 91 degrees. So in order to find arc ABD, I would have to add this 50 degree arc to this 91 degree arc, and arc ADB is 141 degrees. All right, that's more than enough examples for you to hopefully be able to do central angles and arcs. I apologize for the length of the video, but we had a lot of vocab at the start. All right, if you have questions, make sure you check out our office hours or send us an email. Have a good day.